All right, Lady Ada, what is this?
Hey everybody, and welcome to Show and Tell. It's me, Lady Ada, with me, Mr. Lady Ada, broadcasting live from downtown Manhattan. Today, Food Factory is, and we love to do electronics and share and show off electronics, which is why this is called Show and Tell. And we're going to check in with some people from around the community. What are they crafting, making, soldering, coding, restoring, and more? We got some folks from the Adafruit community. Today is a holiday, so it's going to be a little light, but
Yeah,
it's okay.
We'll be
still
showing
have-
off some of the things our staff is working on and more. And we figured today's a paid holiday for our team, but we got a couple things going on, so we thought we'd show and share it with you.
Okay.
So first up, let's go to JP. And you're working on a cool music thing. I'm going to be playing something for the intro of our show later. What you got?
Excellent, cool, yeah. So I'm super excited about this. This is a project I just finished writing up a learn guide for. And you can see it's heavily Feather based. We have a Feather RP2040, which is the USB host version. And then I've got a MIDI out and a little OLED display. And what I'm doing here that's cool is this Feather with the right libraries allows you to host a USB MIDI keyboard. So a lot of modern MIDI keyboards basically have one plug on them, and that gives it, power. That's my microphone. And data, but when I want to hook it up to an old synth or even some modern synths that don't want to go through the hassle of hosting, which is kind of a computery type of task, you're sort of stuck. So what I have here, this is like a 1985 or so Digitech Vocalist workstation, which is a harmonizer, which you may know from the Imogene Heap song that got real famous. I forget what it's called, but it can be used to take an incoming vocal or instrument and harmonize, and you can change what keys and even harmonizing chords you're playing with a MIDI keyboard. Well, to use this little modern MIDI keyboard with this, it's kind of impossible without inserting a laptop in the middle normally. But now we've got this. We've got this little USB Feather RP2040 solution that lets me do that. So what I'm going to do is I'm just going to demonstrate this. I'm going to turn off my regular mic volume, and I'm going to speak through it while I change what harmonies are happening via the MIDI keyboard. All that MIDI goes to this gizmo and then over to that gizmo. So here we go.
What I can do now is adjust the harmonies that I'm playing by changing the MIDI keys that are sent through my Feather. And the neat thing about that is that I don't need a computer.
That's great.
And neat things about so channel 5 for some channel 1, and I don't remember the sort of convoluted way to tell this to output on a different MIDI channel. I can just hit one of the little buttons on my TFT here, and I can cycle among the different MIDI channels, so it's changing that right there. And I can also do some other adjustments to filter the types of messages that the knobs are sending or which program changes are coming through. So I'm really excited about this because this has normally been either a computer or like a pretty darn expensive gizmo, like a $130 box that just kind of does the one thing. But this is something that we can rewrite the code for to do kind of anything we want. So kind of a fun and kind of a big deal utility, but also a lot of fun for people who hook up gear.
That's cool. We'll be playing. You sent me a video. We'll do that at the opener for Ask an Engineer with some music, and then tomorrow people can tune into JP's workshop.
Yes, come on by. We'll be just wrapping this project up. I'll show the learn guide for it, and then we're diving into a new thing involving servo motors.
Cool.
Okay.
All right. Thanks so much, Amy.
A cool invention with a good use.
Alrighty, let's go to Jepler. Jepler, what you got going on?
Hello. So I've talked a number of times about my Xerox 820, which is a early 1980s home or business computer that ran CP/M. And this is the 8-inch floppy box. And one of the things that you think about when you're working with these old things is how do we get stuff on and off the floppies? I got floppies with this. And this is my trusty bootable CP/M disk. But if you didn't have one and you had one on the internet, what would you do if you didn't have a working floppy disk? And the answer is you need to write it with something else, like this board that has been in development for a while. This is the Adafruit Flopsy, But this hard drive doesn't have the same connector pinout. It's got a sub D connector like this. So a couple of months ago, I created a board that would adapt in the other way. It would let me hook the computer up to a floppy drive emulator known as a GoTech. But I realized if you just put the sub D connector, get the opposite gender, and put it on the opposite side of the board, it becomes what you need to plug into the floppy drive, and then it works with the Flopsy. So I just got this working today because the parts came in, and I made an image of bootable Xerox floppy with it and wrote it to the floppy that I have in here right now, and we can boot that up and see some CP/M operating system. This project here is actually on the Adafruit Playground under my name. Here we'll boot from the A drive. And I mean, this is the floppy I use all the time. So it has my favorite old game of Star Trek. So we'll just load that up there, give it a minute or so. But I was really excited that the Flopsy would just work on this drive. I mean, this design of the drive is like late 1970s. There's one little detail that if it was a little older, it wouldn't have worked to write the floppies, but this is new enough that it did work. So I read it off. There was one bad sector on my boot disk, and now I've got 2 boot disks. So I'm really ecstatic.
Yeah, this solves the problem of like to run old computers, you had to have a boot disk. If you don't have a boot disk, it's how do you get the boot disk, especially like with old Macs where you can't use a USB floppy drive. You actually have to write the weirdo format. Yeah,
this is the same thing. This is a weird format that if you could write it on a standard PC, there's no way you could write it over USB. I think some people have figured out how to write this with a PC AT disk controller, but it's a FM format. It's called DEC-RX01.
Yeah.
And it's really strange, these old CP/M formats. And with stuff like Flopsy or with Greaseweasel, you can read and write them, and that's really cool. And yeah, so the plan for this board, if anybody else in the world has a Xerox 820, is up on GitHub, and somewhere I'm going to put some more instructions about how to use it with a floppy archiver like Greaseweasel. But yeah, it works, and I can archive my floppy disks even at a lower level than putting them in here. And that's what I've been up to today, kind of on my day off, as you might call it.
Thanks so much, Jeff. And if you remember, maybe post the links in Discord.
Yeah, I will drop by Discord in just a second and link to that existing playground about the floppy emulator. These are really cool. These are a lifesaver if you don't have media, and you can hook them up to a lot of computers just with the 34-pin cable.
We want to put the Flopsy do this too, hopefully.
The firmware of these is open source, so you can check that out and figure out how it works. But yeah, we'll do one of these someday, a little more. I know. Yeah,
we just flip the direction pin the other way, and then we're golden.
Then we just have to write all the software.
Well, yeah, but I think on one hand it's going to be tough. On the other hand, I think it's definitely easier to write floppy signal than reading floppy signal. Because when you write it, you just blast it out. Like, it's not your problem.
Yeah, I think an interesting challenge is when the floppy is going to be spinning around and it sees the index information for sector 12, and it's like, I want to rewrite sector 12, and then it starts blasting back at you. And I think one of the challenges is going to be getting that data when the computer decides to write, and you don't know exactly when it might make that decision. But we'll get there. We'll work on the code.
But I think because the GoTechs are cool, but they're not open source, and there's no guarantee that they're going to be manufactured with the same chip and the same open. The firmware is open, but there's no guarantee that firmware will run on the hardware.
That's right. It is a little bit of if the eBay listing says this, it's probably this chip. It'll probably work. But,
I'm sure it's like, especially with the chip shortage. I think there's an ST processor in there, and I'm sure they've changed it around a bit.
Yeah, they're using an RTEC or something now, which I think is a very similar to ST, but not quite chip. But it would be nice if this could work on, a wide variety of things that you just build with probably Arduino. I don't think we'll do that one in CircuitPython, but we'll see.
Yeah.
We'll see what we do.
Yeah, we'll see. We'll get there. It'll be definitely a PIO challenge. Okay, cool. Good to see the Xerox alive.
Good night.
Good night.
Okay, we're going to go to Mouse, then Flying Things, and then Mark. Mouse, take it away.
Hi. This is a finished project. I showed the work in progress a few weeks ago. This is a asteroid impact warning device.
Ooh.
Yeah. So
If only dinosaurs had DIY electronics.
yeah. The NASA Jet Propulsion Laboratory runs a system called Sentry that keeps track of asteroids that might hit the Earth. And there's a website and a web API. This started out as a Python program on my computer to warn me of any changes in the status of asteroids hitting the Earth. I decided I wanted a standalone device, so I ported it to CircuitPython. I found actually this project is based on a jepler project on the learn.adafruit.com. So there's a PyPicoW, sends a request out over Wi-Fi, and if there's anything, it asks for the most dangerous asteroids, and if there's anything changed since the last time it checked, it displays an alert and plays an obnoxious sound. So I'm going to turn it on. This is USB power, it's USB power only right now.
It's a good idea. It's kind of like those single-serving websites where they have a celebrity and like, are they dead yet? This is
you could do that too. Yeah, except you'd be wrong. Yeah, you'd be wrong. They just declared Noam Chomsky dead erroneously the other day. So I'm going to turn it on. Warning: there will be a loud sound in a few seconds. It initializes with some dummy data, so the first time it actually checks, it will get a result that there's an asteroid. Takes a few seconds to boot up. There we go.
Go away.
Okay, so an asteroid's going to possibly hit the Earth in what is that? 2880, the year 2880. Threat level none, which is not very severe, so you don't need to start stocking up on canned goods just yet. And it's going to keep that a message up until I acknowledge it by pressing the button.
Yeah.
And then it'll fetch data again, find that nothing's changed, no new threats, and it'll check every hour from now on. I can show what's inside. I haven't buttoned it up here, so I can show you what's inside. You probably can't see it.
Yeah, I can see it a little bit.
It's getting dark here, but there's a Pico W. There's a OLED display here on the front, obviously. There's a I2S amplifier BFF there, hanging in midair, connected to the Pico W. And way in the back, there's a speaker in the back corner, and lots of hot glue.
Yeah. This looks great. If you want, toss it up on playgrounds, or you can send a note to our team and we can cover this. I think this gives people a lot of good ideas for like single-serving data things.
Okay. Yeah. Who should I send a note to?
Yeah.
Supported Adafruit.
Yeah.
I'll post links in the Discord.
Yeah, that's great.
Okay. Thanks.
Great project. Thanks, Nat. All right, we have till 2880, so we got a little bit of time. We'll be doing show and tells then, so we'll see how it goes.
Yeah.
Alrighty, let's go to Flying Things, and then we'll go to Mark. Flying Things, what you got going on?
Yeah,
Latest and more.
Hi, I added some more facial expressions.
Yep.
So I got, XD. I got angry.
Yeah, I like the angry.
Her.
And then wide-eyed.
Yeah, it looks kind of surprised.
And then ooh woo.
Oh yeah.
So yeah, that's all I've been working on.
And you get some pins too.
Oh yeah.
Nice.
And for the folks at home to catch up, so you're using gestures in some way to change the eyes.
Yeah, so I'm using the pop pads, the conductive.
Yeah.
And they just complete a circuit on the back.
That's cool.
And that's all. That's all I wanted to show.
All right.
Great.
Keep coming back. This project continues to evolve.
Yeah, I love seeing the improvements, and that's such a
cute thing. You can now react. Real time to what's going on.
Oh.
All right, Mark, play us out.
Well, once again, I'm not nearly as cute as the last project. I'm sorry. But I thought I'd also give an update on some of the weather stuff I've been working on, as people have been asking me. So, start with, I've got the anemometer, which I can never say, actually working and spinning now. Underneath is a little circuit board with just a reed switch mounted on it. And on the top part, there's actually space for a magnet that fits in here, which is triggering it as it spins around. Then pretty simple at that point, just completes the circuit to count the wind speed with a little bit of math, which I have not done yet on figuring out how fast this thing is rotating. And then the other part of it is to pick up the direction. Hopefully this holds. I just glued it right before show and tell. So similar concept, it's just a bearing holding the arrow. It seems to finally be fairly balanced now. The latest design in Fusion actually has a cap. But what I have to do on this one is there will be that diametrically aligned magnet that will go over one of the sensors I was testing that will be able to give you a fairly precise angle of the direction of the wind
Very cool.
once I have finished updating it.
Alrighty, so that's the latest. So how close to this project getting deployed?
Good question. I've barely had any time in the last 2 weeks, which is why it's just a minor update now. So at 5 minutes a day, well, hopefully before the asteroid hits.
Yeah, you have some time.
Yeah.
All right. Well, thanks so much, Mark. And keep coming back. I like that people can see this project progress over time. And then eventually you'll be sharing data or publishing some type of data once it's recording wind speed and more.
100%. I've still got my subscription to Adafruit.io, and it works perfect for this sort of thing.
All right. Well, thanks so much, Mark.
Thanks a lot.
Alrighty, that is our show this week. Got a bunch of Adafruit folks and folks in the community. Thanks for sharing your projects before the asteroid hits. We'll see everybody next week. Don't forget, Ask an Engineer is 8 p.m. Show and Tell is Wednesday, 7:30 p.m. Eastern Time. Every single week, someone from Adafruit is here, and this is where you can show and share your project, show off retro stuff, and more. Lots of new things or new old things. Combination of retro, new meeting the old with a lot of technology. See everybody on Ask an Engineer. Bye-bye.
15 minutes. See you soon.